Let us take a look at this question. If fx equal to, okay, cos minus sin x 0, sin x cos x 0, 0, 0, 1, show that fx times fy is equal to f of x plus y. This is what we are asked to do. This is a very special matrix. It is sometimes also referred to as the transformation matrix. Transformation matrix, yes. This kind of a matrix has its applications in transformation. In transformation, yes, transformation of axis and transformation of axis. And what kind of axis transformation are we talking about? We're talking about actually rotation of axis. Which axis? In the coordinate plane. Oh, a lot of complicated things are coming over here. It's not very complicated. You may remember the Cartesian plane, right? In the Cartesian plane, for any point located at some particular location with reference to some x and y axis, some coordinates would exist, right? In case you rotate, what do you mean by rotate? In case you rotate the reference that is the coordinate axis. Okay. Location of P, the new coordinates for that location of P, the new coordinates can be obtained with the help of this. Okay. And for a two-dimensional plane, only this particular part would be required. But for 3 dimensions and in some particular coordinate system, yes, the cylindrical coordinate system, what you have is a difference. In polar coordinate system, what you have is you will require this particular kind of a axis, this particular kind of a transformation system, right? So is that all required? Is all of this information required for solving this question? No, nothing is required for solving this question. We can solve this question very easily over here. Let's approach the question. Okay, capital Fx is equal to this. So in this equation, what are we supposed to prove over here? Let's see. To prove, we are supposed to prove that fx times fy is equal to f of x plus y. This is what we are supposed to prove. Now f of x is simply this. F of y would be, actually you have to replace these x with y. Then you have to multiply and see whether it is equal to f of x plus y, which is this x being replaced by x plus y, this x being replaced by x plus y, x plus y, x plus y, x plus y. Okay. So let's begin with the LHS. Okay. LHS is fx times fy. Now what is f of x over here? This matrix. This matrix is cos x, sin x, 0. What is this matrix? Minus sin x, cos x, 0. This is 0, this is 0, this is 1. This is f of x, right? What is the matrix f of y equal to? F of y is another matrix. This is in product. Another matrix where this x should be replaced with y. So this becomes cos y minus sin y. This is sin y. This is cos y, right? And rest of terms will remain as it is. This is 0, 0. This is 1. This will be 0, 0. That is it? Yes, that is it. What about the product of these two matrices? Let's write the product of these two matrices. This is a 3 by 3 matrix. This is another 3 by 3 matrix. And the product can be obtained by multiplying this row with this column to get the first element, A11, right? Let's do it. This is cos x, cos y, minus sin x, sin y. Okay. So let's write it minus sin x times sin y. Okay. This is this element. There's lack of space, so I'm writing it in a compact form over here. What next? For this element over here, I'll have to multiply the first row with the second column. You get cos x minus sin y. So minus cos x sin y minus sin x cos y. This is the complete term. Okay. What about the last term over here? This row gets multiplied with this. What you have is cos x times 0. Okay. Minus sin x times 0 and 0 times 1. That's pretty interesting. Cos x times 0 will be 0. Minus sin x times 0 would also be 0. And 0 times 1 will also be 0. This is actually sum of 3 zeros, which is 0 only. Which will be 0 only. Yes. Yes, obviously. This is what you get. So that's the complete first row. Yeah, that's the first row. Let us draw the boundary of this matrix. What about the second row? Second row is obtained by multiplying the second row with the first column, with the second column, and once again with the third column. Let's multiply with the first column. What you have is sin x times cos y. Cos x times sin y plus cos x times sin y, and 0 times 0 is 0, right? What else? Let's multiply the first row with the second column. Sin x minus sin y, which is minus sin x sin y. Cos x cos y, so plus cos x times cos y. What next? This row gets multiplied with this. We have sin x times 0, which is 0. Cos x times 0 is 0. 0 times 1 is also 0. So this element over here would be actually equal to 0 only. Take a look at that once again. What next? For the third row, we need to multiply this with this, this again with this again with this. Right? Let's do it. So 0 times cos y is gone. 0 times sin y is gone. 1 times 0 is gone. This is all 0. Big 0 over here. Similarly, the second element in the third row, 0 times minus sin y is 0. 0 times cos y is 0. 1 times 0 is also 0. That's pretty simple, right? What about the last element? The third row, third column. 0 times 0, 0 times 0, 1 times 1. What will that be? That will be 0 plus 0 plus 1. This will be 1 over here. You can observe that easily? Yes, you can observe that very easily. What next? Can I simplify this expression somehow? Yeah. What is this? This is cos x cos y minus sin x sin y. Cos a cos b minus sin a sin b is actually equal to cos of a plus b, that is cos of x plus y. This here is actually equal to cos of x plus y. Yes? Yes. What next? Can I take a minus common from here, right? This is minus cos x sin y, sin x cos y, right? Let's take a minus common and what we get is a sin x cos y plus cos x sin y, right? Let's take a minus common and sin x cos y plus cos x sin y. What is that equal to? Sin x cos y plus cos x sin y will be equal to sin of x plus y, right? From trigonometry. This is 0 over here. I'm not worried about that 0. Okay, what about this? This is sin x cos y plus cos x sin y, which is obviously sin of x plus y, right? You see, this term is actually the negative of this term only, okay? So this term is actually the negative of this term only. What about this one? This is cos x cos y minus sin x sin y. Same as this, right? This is cos x cos y minus sin x sin y, which is cos of x plus y. This is 0 again. And the last row is 0, 0, 1, as you can clearly observe from the top. And what is this equal to? Let's compare. Cos of something. Cos of x. Instead of cos of x, you have a cos of x plus y. Instead of minus sin x, you have a minus sin x plus y. Instead of sin x, you have a sin x plus y. Instead of cos x, you have a cos x plus y. For these 0, 0, 1, you have a 0, 0, 1 correspondingly. So we have replaced this x by x plus y. We can replace this x by x plus y, and this can be written as f of x plus y. That is something which we wanted to prove, yes. And yes, we have started from the LHS and we have reached the RHS of this statement. And that's the complete proof of this question over here. Is that all? Yes, that is all for this question, as you can clearly see on the screen.